Welcome to another exciting episode of OnTech 360, your go-to for new technology. Today, we are thrilled to welcome Gene Halsey, Managing Director for Americas at VIA Optronics. With over 2 decades of experience in the electronics industry, Gene is an expert in advanced display technologies and a passionate advocate for innovation. VIA Optronics is a global leader in optical bonding, touch solutions, and display enhancement technologies. In today's video, we will explore the unique challenges faced in medical display applications, from ensuring pristine optical quality to seamless glove operation, improved brightness, and compliance with strict medical regulations. VIA Optronic tackles these hurdles head on. Gene will also shed light on how optical bonding and touch technology can enhance performance, durability, and reliability in these critical devices. Whether you're curious about the science behind glare reduction, glove-friendly displays, or touchscreen performance in even the toughest environments, this episode is packed with insights you don't want to miss. So get ready to discover how VIA Optronics addresses the medical application with their technology. Let's welcome Gene Halsey.
Thanks, Susan, for the opportunity to talk about medical displays and how VIA can help customers enhance their displays and make them appropriate for medical applications. So first off, VIA Optronics is headquartered in Nuremberg, Germany, with offices all around the world. We have production facilities in Nuremberg, as well as production facilities in Suzhou, China, Japan, and Manila, Philippines. We have engineering capability and sales in the other offices around the world, but it is truly a global company with a focus on this type of application. When we look at medical in particular, there's some challenges that are unique to the medical space, right? That don't necessarily show up so much in other industrial applications, right? First and foremost, displays need to have exactly what they need from a contrast and brightness standpoint. The optical quality of the display in many of these medical applications needs to be 100% pristine. They need to work in really strong chemical environments, live up to disinfectants and other kinds of things that are going to get on there. All of the operators, or many of the operators, are going to have gloves when they use this, so you need to have seamless glove operation with no failures in the touch display. You obviously want these to last a long time if you're going to invest the kind of money that goes into medical displays. And then they need to be able to handle regulatory compliance, the regulatory compliance being very different for class 1, class 2, class 3 medical devices that are out there. And VIA can help a customer walk through what the component level regulations would be in making sure that they can meet those compliance standards. So how do we do that? Right, VIA is a full service supplier when it comes to displays. And when I say full service, it means that we can address a number of different layers of the display and make it unique to a particular application. So if you start at the top layer, cover lens, we can do flat cover lenses, curved cover lenses, glass, plastic, whatever the need for a particular application is, decorate it with whatever a customer would like. And then marry that with a touch solution if the customer wants a touch solution, right? And again, like I said in the previous slide, a touch solution that's really drilled into what the medical requirements are from gloves, water, contamination, other things that may be unique to the space. When it comes to the LCD, we can work with both open cell LCDs and full LCM modules. Many of the medical applications, you're working with LCM modules. But what we can do with the LCM module then is we can take and modify the backlight to meet any particular requirements, be it brightness uniformity, contrast, higher brightness, pixel defects, those types of things. We can add different films to that, and I'll talk about that in a slide or two. And then we can package the whole thing up into, we call it a display hinge up assembly, right? So we can put it into a package, we can put it into a bezel, we can put it into a housing, be it a die cast housing, a plastic housing, whatever, again, the needs are. When we marry these layers together, the cover lens to the touch panel and the touch panel to the display, that's really where the optical bonding expertise that Susan touched on comes into. And when I when we talk about optical bonding, the max view process is what makes VIA really unique in the market when it comes to this bonding technology. What max view deals with is it puts the adhesive on the cover lens or the touch panel rather than putting adhesive on an LCD. Most people, when they optically bond displays, they put the adhesive on the LCD layer, and then they present the touch panel or the cover glass to that adhesive and squeeze the two together. We do it very different. We put the adhesive on the cover lens, and then we actually pre-cure that adhesive to make it a sponge or a jelly, if you will, right? That has a pre-cure characteristic to it. And then we take that and we very gently present it to the LCD. So there's no pressure that's being placed on the LCD stack. That becomes very important in medical when you talk about optical defects and other kinds of anomalies that you may introduce to the process with the addition of pressure from traditional bonding techniques. This process is scalable. We can go from very small sizes up to 84-inch. We've got medical applications in Asia that we're working on in the 55, 65, and 80-inch space for this process. And again, when it becomes optical clarity and purity is really important, VIA is well suited to be able to deal with that. The material that goes into that optical bonding process, the MaxView process, it's a resin-based material, right? So it's not a traditional UV curable or what a film-based material. It's an optically clear resin. And there's some benefits to optically clear resin that are noted here. The big one when you talk about medical again is that clear, transparent, and non-yellowing. This isn't going to change its optical characteristics over time. It's not going to shrink over time. So if I put these into a very life-critical, patient-critical type of applications, I don't have to worry about delamination. I don't have to worry about color changes. I don't have to worry about the types of problems that may come up from other adhesive technologies being in an operating theater, being at a patient's bedside, those types of problems that may come from alternate technologies. It has high elasticity. It has adjustable hardness. So if for some reason a customer wanted something really to be changed, they wanted it more rigid, they were putting it into some kind of housing where they needed a different rigidity of the lens to display structure, we can adjust the hardness because it is a resin material. We can adjust that hardness to whatever that requirement can be. Again, if we're talking about in a patient's room, non-toxic, environmentally friendly, these are things that you really want. You don't want to be introducing harsh chemicals into these applications if you don't need to. And the resin that we use is environmentally friendly. So as I talked a couple minutes ago, there's other enhancements that we can do to the LCD to make it higher bright, higher contrast, right? We can do that with just optimizing the stack that's in there, right? So that passive brightness enhancement that's noted, right? We can tear apart the display and do some passive enhancements without adding additional power. Or we can do active enhancements where we add additional LEDs or other types of luminance mechanisms to increase the brightness of the display. We can also add films, right? We can add brightness enhancing films. We can add polarization films. Whatever the need is for that, we can add those into the stack where they're appropriate. The mechanical frame and bezel. Right? We may find, as we did that display hinge up assembly I talked about, we may find that tearing the display apart and packaging it in a different way allows it to go into the ventilator, the heart monitor, whatever it may be, in a more appropriate way for that particular application or that particular customer. And we're able to do that with some of the enhancement techniques that we've got, particularly in the Nuremberg facility. We can change the mode of the LCD, excuse me, tripping over my own tongue. We can change the modes from transmissive to transflective. If for some reason we're dealing with someone that wants to take these outdoors, wants to take an AED outside and bring it to customers, we can change the illuminance characteristics of that display into a transflective, so it's very easy to see in the sun. And then the other benefit of optical bonding that most people are aware of, right, is you really do increase the contrast. You get rid of those reflection layers that are inside that are very damaging to the optical clarity. That comes from anyone's optical bonding, but again, we feel like resin, given its stability, its color, and other things, is the best alternative for what's out there in the medical market. Finally, I want to talk about touch. Touch has become so pervasive on all displays today, and you see it in many different places, but it is still a challenge, particularly with projected capacitive, right? Projected capacitive is a technology we all know from our phones and our tablets. It's the number one technology that's out there today. Projected capacity, because it works on the idea that when you touch the screen, you draw a small amount of current off through your body and off to ground, becomes a real problem with gloves and other types of things on the surface, water, saline, other kind of contaminants that get on the surface. So you need to be very skilled in developing firmware and a controller set for those sensors to be able to handle those conditions. And VIA has spent a lot of time and energy in developing platforms with our IC partners to be able to do just that. So we can make sure that we can put multiple layers of latex gloves on and still be able to activate the screen. We can put it at a patient's bedside and know that if you hit a button, it is going to work. You're not going to get false touches. And it can meet those regulatory compliances that we talked about at the outset of this, right? And the other thing, if I take these then outside and bring them into an outdoor environment, marry them up with the optical enhancements that we talked about, and still be able to deal with rain and other types of things that are getting onto the screen that may cause the touch not to work. So we tune around all of those different things. One quick example that we've worked on in the past, right? We're able to tune touch controllers to be able to work in certain frequencies. And that becomes very important in the medical space where you're worried about not just radiated emissions, but conducted emissions of the displays that you're talking to. So we may have, you as the manufacturer may have a frequency that a device can't operate on or operate in because you'll get interference with your own device. We can work around that. We can tune the controller and the firmware to exclude those frequencies and make sure that you're protected and that the device isn't going to have any interference from the touchscreen. So to wrap it up, I mean, this is kind of a busy slide, but VIA meets you wherever you want to go along the journey, right? We're a display enhancement and a touchscreen house. We've got a lot of engineering capabilities and consultative engineering that we want to bring to our partners, and we would very much appreciate the opportunity to talk to you through the Kilfoyle team and find ways that we can explore this market together. So thanks for your time, and thank you, Susan, again for the opportunity.